How are you?
Very good.
Professor Chen. Hi, Professor Wu. Hi,
Hi,
everyone.
hi, Dr. Chi.
I saw we got two new people here, Yu Zhang and also Nazat. Do I pronunciation is correct? Yeah.
Yeah, it's Naziat, but you can call me Ikra.
Okay,
Please
Nazir.
call me Ikra.
Oh, Ikra. Okay, Ikra.
Yeah.
Okay.
Yes, thank you.
Okay.
Nice to meet you, Ikra.
Yeah,
Yeah.
thank you. I have gone through some tutorial, but I haven't gone through all of them. I'll try to cover it by the next week. Yeah.
Mhm. Excellent.
So actually, Dr. Chen, this week there are two new students
Okay.
in our class.
Okay. How many for the student?
So currently there are 12.
12. Okay. Okay.
Uh-huh. The other one is
Mm-hmm.
Gu Rongqing. But I think he's not here today.
So next semester, Dr. Lee and I offer a GIS course. No, because GIS very popular, be used for a lot of government agency, for company, like a mapping, showing, the presentation. So one professor in our university, he will retire this year. So, but this course is very popular in our school. That's why, so I was a volunteer to take over, there's a course. So we will offer this course, but we still learning. Okay. GIS, we had a book, just a course of training, go through the whole book, whole book manual. So then teach student how to make a nice figure, like a nice animation, something like this. Lot of government agency, like also company, if they hire people, they require, people require their employee know the GIS.
That'll be a wonderful course.
Yeah, because you had a lot of mapping issue.
Yes,
Because
yes,
of data, for example, which area you can be fishing, which area not
right.
fishing. You can, they have to use a lot of database, like us, map database. So
That'll be a wonderful course. I hope, is that course also open to the people like us?
no, this course, this is not like a non-credit course, it's a credit course. But most time our university had a 30 student, most like a data science, like other people to take the course. But so the university don't allow us offer as a non-credit course. But if you take a credit course, you have to pay a lot of money. You have to pay the $15,000, no, $1,500. $1,500 for credit course, right?
Yeah, yeah.
But it's a lot of money. It's not a non-credit. But I can ask her, is it possible at a non-credit, also? Had a student say, but before university don't let offer a course at a non-credit and a credit at the same time. They have to separate it.
Okay. Professor Chen, I'm sorry for cutting your saying because I think this 1 hour is not enough time for sometimes
Yeah.
maybe not enough for answer all the questions. So I suggest that I heard that this week several students have many questions. So I suggest that why don't we listen their questions first, all of them first, and
Okay.
then you can answer as the time
Oh,
allows.
that's good. That's good suggestion.
Yeah,
Okay, let's do that. Okay.
okay,
Let like Dr. Lee start
okay,
the course because
yeah,
sorry, I thought now it's 5 minutes past. Sorry.
yeah,
Okay.
Yeah, thank you, Professor Chen and Professor Wu. So, before this discussion, 5 students from Professor Wu's lab already sent their questions here. So maybe we can start from this question. So first, I will just make things very short. So first, for this week, we will discuss with lecture 6 that's about the wet dry treatment. And for every discussion, we also have a record as is shown here. So if you have any questions or you want to review the last discussions, please go to the YouTube website so you can see all the discussions from lecture 1 to lecture 5. So that's all from me. So this morning I received the questions from Professor Wu's students. So maybe we can first start from here. How about we start from this question?
No, Professor would suggest let student present their question first. So then we can let them present all question one by one. We don't give answer until they finish all the presentation, the question, so we can answer one by one. This way we know how many questions there are. It's better
Okay.
understanding.
Okay.
Otherwise, we spend too much time on one question, probably the other student probably don't have a chance to ask a question.
Yes.
Okay.
We can relate it, we can answer together, you know?
Yes.
Okay.
Yes.
So
So who wants to start the first question?
I want to start first.
Yeah.
Oh, I can share my screen, so I just
please try it again.
okay. Okay.
Yeah.
When in lecture 6, you introduced the study about tidal creek by using wet dry module in FVCOM, and I wonder, there is a lot of topography like a channel link like a tree branch. In the small case, tidal creek is one of that example, and in a large case, I think the fjord is one of that example. So I want to know, when we set the numerical modeling, how can we decide the to to get that impact on the model domain? Is there any some way to decision that kind of thing?
Okay. Yeah, I see your question. Okay. Yeah. Okay. That's good. Let us go to the second one. I will answer the question for you. Okay.
Okay.
Who had a second one?
Can I share my,
Yes, please.
자, 오케이. 준영하고 민우, 지명, 윤성 요 순서로 합시다.
okay, can you see my screen?
Yeah.
Yes.
Okay, the FVCOM developed team designed the idealized case experiment to examine numerical instability due to the non-conservative volume in the wet-dry transition zone under the case of I split is not equal 1. So I understand that this experiment was conducted to determine the optimal I split value in intertidal environments. So when minimum depth was set to 5 centimeters, it was suggested that steeper intertidal slopes require larger I split values. But I think with the same water level changes, the gentler slopes create more wet-dry transitions and greater instability. So my question is, shouldn't gentler slopes need higher time steps rather than steeper ones?
Okay, that's a question, so related to first question. So we can answer together later. Okay.
Okay, can I share my screen?
Yes, please.
I want that when using modus pre-time integration method, calculating water traffic in the external time step can lead to difference in TC area between time steps as the sea level changes. I also want that mass conservation occurs in both time step when I split is 1, but mass conservation issue may arise when I split is not 1. For model split method, I think error can accumulate in intertidal zone, result as adjustments are made for mass conservation at each intertime step. Also, when simulating intertidal zone using a semi-implicit method, can we obtain more accurate result than the model split method? Model split method, and what problems occur when simulating intertidal zone using the semi-implicit method?
Okay, that's related. Okay, I know that. Okay, later answer later. So 3 questions. One is about a resolution. Second one is related to, the front drive and smooth topography, rough topography, or time step you should choose. So why third one is mass conservation issue. I will talk later. Okay. So I have other more question.
Yeah, 2 more
There are
questions.
also 2.
빨리빨리 좀 해.
Can I share my screen?
Yes, please.
I understand that the dike and drone module functions well using MPI computation environment in FVCOM situations. When there is no dike, if there are 100 nodes and they are divided into 10 partitions, the partitions are generally distributed such that some contain 8 nodes while others contain 12 nodes. However, when a dike is present, the partitions are divided differently. I would like to understand why this difference occurs, and I have identified that the difference in partitioning causes errors due to MPI. To resolve this issue, I'm considering partitioning the model with the dike in the same manner as when dike is present. I believe this approach could mitigate MPI errors. Is it possible to manually partition the model in this way? This is my question.
Okay, that's why. Okay, that's the way we can talk about this. Okay. Okay. Another one. Okay. Yeah, we can talk about later. Okay. That's different from the previous 3. Okay. So which is this one?
This is the
준영
last
마이크가
one.
꺼졌어.
I have some questions. So, you said that if the ratio of internal mode and external mode is 1, the mass is conserved. But if the ratio is more than 1, the mass will change. So mass is not conserved. So I don't understand why, if the ratio is more than 1, mass is not conserved. Why it cause this problem, and how much does it change?
A similar question, like a third one. Okay.
Yes, it's
Okay.
similar. Yeah.
So is there any other question?
No. So let's start to answer the first question. For inundation, what kind of resolution you need, you post a question there. So it's hard to say. That's depend on what you need to resolve. Okay, for example, in the case you show the picture I show you there, so we do the model with the tidal creek, we do have a resolution coarse resolution include all river. So we also did resolution with a high resolution with only few meter. So that's really issues, depend on the two things. One thing is what kind of data you have. Okay, if you don't have high resolution perimetry data, your resolution not help you. Okay, so because you put a high resolution model, but your perimetry too smooth, so increased resolution, does not help you to resolve a better, flooding. Okay, so then the question when you have a very high resolution, like we have 1 meter resolution data, 1 meter resolution data, so that means all the detail we can resolve is 1 meter. But sometimes, we really need to consider about, 1 meter costs a lot of computation time, right? 1 meter region, whole region is very computation time. That's why, we most of the time we just say what question you address to. Are you interested a particular flooding area for certain area, or do you think about all the detail? Okay, if you see the all detail, you have a high resolution, at least the resolution be same as your perimetry data. Right? For example, your perimetry data 1 meter, you should go to 1 meter. But then most time you're not able to do that because of competition time. Not spend the competition time. That's why you can do like we found the region here, really depend on question like we do the Massachusetts Bay, we find if we want to resolve, the flooding for the street, for the water come here the storm, so they have a lot of house, resident house nearby the coast. But this area, so those people more intention, so we want to make sure more accurate resolve that. That's why we had to make a resolution really high in that area. Though we depend on area, not, but when some region like most of wetland, nobody live there, right? So you don't need to have a high resolution over there. That's the infrastructure grade, good because they're flexible. That's why you don't need with a high resolution. Really depend on the question, what do you want to address? But then what we are focus system in the US right now, we are resolution, we use a 10-meter resolution. So we found a 10-meter resolution, we can tell people what the region can be flooded. But we're not able to tell you which street can be flooded, which house can be affected. Right? So then we determine what house affected, we have the resolution at least of 2 meters. Right? So you look at that's why, but total water flooding similar, right? Total water similar, that the spectral distribution could be different when resolution increase. So that's why what the resolution you need really depends on what the question you want to address. So there's no criteria said what what I have, but the bottom line is your resolution, the maximum highest resolution used is the resolution same as the perimetry data. Right? That's the bottom line. Just like if you had a 1 meter resolution, like LiDAR data is 1 meter resolution, you maximum can choose 1 meter. If you choose 0.5 meter, doesn't make sense because your perimetry do not resolve it. That's the bottom line. So then what the really resolution I want you depend on the question. Okay, how you do that. Okay, right? For example, for your case right now, for nearby the Greenland Sea there, you see a lot of areas there is very detailed. If you're really interested, ice melting the locally, local the street there, so you probably need a resolution a couple few meters. Okay, but this island, this region was no many people stay there. You probably don't resolve each house there, so you probably don't need to go to like a 1 meter resolution, right? So what tested over there, we use a 3 or 4 meter resolution because we do see the converging study. We run the model for 10 meter, then you see, I do the whole region, 10 meter region, so then I reduce the 4, I can resolve the whole flooding. The timing flooding is much better. Okay, so that's why when we do the comparison, we use like a remote sensing, right? Yeah, we use the remote sensing measurement, see what is the flooding area is, what timing. That's why we run a model, change the resolution, see what the resolution we need. We can resolve this kind of opposition field. So if you really want to know how accuracy, you have to do observation, to see what resolution you need. Okay, like we did before. Okay, the second question. Okay, that's first question. Second question, can you post the second question again? Yeah, second question, that's really interesting. Okay, so you said, slope, you consider one way, you think about if, generally topography, one times fronting area is bigger, right? So that's why you said the time step could be smaller, but not really true. Most problem model instability control, if you only have a fronting like one direction, model is very stable. Okay, because one direction fronting goes this direction, but sometimes, if you look X-ray, the water comes from different direction. Right? For example, Tidal Creek, they had water come from main river, they have Tidal Creek come here. So a lot of corner region, the big change there, the velocity can be big converging, diverging over there. Right? So when the steep topography very steep, you not consider how high the water is, how large the area is. You need to consider how the sea level changes during the one time step. Okay, so then the instability, numerical instability, really dependent on the sea level change during the one time step. When you have a steep bottom topography, the sea level can be changed quickly. One time step can be, the difference can be larger than your general topography. So that's the reason you have steep topography, you always choose the smaller time step. Then the general topography, the water just very straightforward, organized, not a lot of, most, if very general topography system is more linearly compared with the rough topography, the steep topography. That's why the instability really depends on the sea level changes, water level changes during the one time step, not dependent on the area be flat. Okay. You see what I mean? Because the time step already very small. So that's the reason, okay, you better just use like a smaller time step. Okay, the steep topography, then the general topography. The second one is also we talk about a slip the one, because more if you get a more slippery model, four things, something I write probably not accurately. No matter semi-implicit skin and implicit skin you choose, mass not fully conservative. Okay, not fully conservative. I mean the mass conservative is means flattening time. Flattening time. Okay, that means, okay, because you only the flattening time, if you slip the numbers one, you get a more conservative the mass, because the time you're doing this one, because you don't have the message, you don't lose the water. Because when you integrate for multi-time step over there, so barotropic mode, baroclinic mode together, so they not be conservative, because you certainly get like a water, lose the water there, but most non-conservative happen in the draining the water out. Just if flooding, you'll be conservative. No any problem, right? For when the waters withdraw the water from the wet become the dry, right? Because from the wet to be dry, but sorry, from dry be the wet, it's the method conservative, right? So then you use like a third question. If you use semi-implicit skin, so you guarantee conservative only for flooding period, but not for ebb period. Okay, I see the most clearly because mass conservation only just doing for flooding period. We only test the flood, not for the, so not for wet period, just like when the water withdraw, after flooding, we joining back to the estuary. This time, the reason is when it's sear, before it's dry, before it's wet, okay? Now, before it's dry, from wet, from dry become wet. That's when the water enter into the region. That's easy understanding. You can advection enter in region. But when if the water leave from the region, become from the wet, become the dry, we are a treatment for wet dry pond is empirically just here, okay, sea level lower than the minimum, we let them dry. But when the sea becomes dry, the water is loosed. And the water did not put back in the well.
So what if that minimum depth, which is like
yeah.
5
Okay.
centimeter, could be reduced to, let's say, 0.1 centimeter?
Okay,
What
yeah. Yeah, that's a good question. So we put a 5 centimeter. The reason is a topographic coordinate. Topographic coordinate, if you, when the back depth becomes 0, topographic coordinate is a fair. Okay, so your topographic transformation, you can write down very similar. The region there, if depth equal to 0, the sigma equal to infinity.
Mm.
Okay, that's why your topographic transformation is not working when the depth completely becomes 0.
Mm. Mm.
Right? So that's the reason, it's the best way to see the problem is called a moving boundary. Okay, but moving boundary is hard to do because you have to every time to create a seal. How much water create a seal? It's not a very practical. Can make you can write a select, you can write a paper, select paper. You can moving boundary how to treat, but the really topography is so complicated. A lot of estuary creek, really hard to determine where the boundary is for flooding region. So then you have a sigma coordinate transformation or other topographic coordination. So your depth cannot become 0. Right? So then you have to put some depth, put some minimum depth there, make sure your coordinate not go to 0. But if you put it too thick, when the original one, the model development for the flooding draining, most people put a 20 centimeter. If you put a 20 centimeter there, okay, that means every place is 20 centimeter there, so that this bottom boundary can move. Right? Because you're too thick, the water whole layer the velocity can move.
Yes.
Right? So that's why if you, for example, you run for flooding draining, so you put a 20 centimeter depth there, your model always stable. Okay, no any problem. Okay, but then the problem, so we test a lot of way. So we found if you put a two thing like 1 centimeter, model very easy because you get a 1 centimeter, you got a turbulence mixing, a lot of things there. So model could be easy blew up. So we tested, we find a 5 centimeter is very reasonable. That's we show the people what has happened, right? Time step there. But this all is a picture shows you for idealized case. Right? When you do a very really case for estuary region, because you got flooding draining for different regions there, you got a tidal creek, sometimes at the vacuum turn with the water from very big changes of precipitation, so that's can cause overshooting issue. So that's the reason we have a limit, 1 limit 2 into the model coding. When you do the estuary flooding draining, you better turn on the limit. If you don't turn on the limit, because currents go to different direction, come from sensor, the big converging, diverging in the local area can cause like a model blow up.
What kind of limit are you talking about?
But
The depth?
vacuum limit.
I'm sorry?
The vacuum limit.
Oh.
So in the coding, if you make in qualify, you can see the vacuum, you can limit 1, limit 2, right? So most of for estuary, for flooding, very complicated topography, you should turn on that
Advection limit.
limit, because this cause overshooting. But this testing don't have a problem because it's so idealized, right? Linear topography like this way, but when you go to real case, it's not like this way, okay? So third question you ask is, if I use semi-implicit skin, does the method conservative? Okay, answer is not really. Just like I answered the second question, it's only conservative for flooding period. When the water from wet to be from dry turn to the wet, because you get a water in there, you know how much water get in there, how much water lose other region. That's conservative. Okay, so they for the most liquid coating, because even for this period, so they have a barotropical mode, the baroclinic mode not consistent each other, right? So this way, semi-implicit skin is more accurate than the most liquid coat for flooding period. But however, both methods cannot conserve mass when the water draining from the wet to be dry. For example, supposedly you have a water with this is triangle be flooded, okay? Before it is dry, now becomes wet. When the water withdraw from the triangle, change from the wet to be dry, right? So we just use a criterion and say, okay, when they lower their minimum depth, we assume it's equal to 0. So where does the water go? It's supposed it's water reminder is there, should we go back to the wet triangle, right? But we are just treat it as 0. Just treat it as a 5 centimeter, right? Just assume it's dry. The water is loose. Okay, so that's why if you do the idealized case, wet dry point treatment, you can see the water. If you don't have to continue put the water in, the volume of the water is losing, because your treatment empirically for the drying treatment. I can draw the picture for you. I can show you what really happened. Okay, I can show you the picture for you here. For example, you had a triangle here, right?
Dr. Chen, are you using the okay? Now I can see. Yeah.
Water was coming here is a boundary, for example. Here triangle, okay, before it's dry. Now water getting in, so this water pushing into this becomes wet. Right? So next time when the tide change direction, this water draining back to the estuary. So this region, when the region here, the minimum depth is smaller than close to the 5 centimeter because we get 3 point, compare sea level, the compares all the SAIL criteria. The certain criteria is averaging 3 point is lower than your minimum depth. So then it becomes dry. So suppose it had water. Because they're close to be dry, they should have water there. But the water is supposed to be moving into the wet triangle, but we didn't do that. We just assume it's 0. That means the water is losing in this triangle. Just manually treat. The water is become dry because still have water there. That's why in this way you're not able to keep the wet dry point. You're not able to keep water conservation anymore. Okay, because you treat it after you treat it. The best way you do say if you leave the triangle be dry, you should calculate how much water remains there, then put the water into the wet triangle, right?
Yes.
But we didn't do that. Okay,
Yes.
too complicated. Right? So you don't know, you should have put this triangle or should have put that triangle. You should have put this triangle or should have put this triangle. You just compare because this water loss is very small, not very big, right? Because you're close to be the 5 centimeter. That should be a little bit of water loss. That's why you're not able to keep the mass conservation. I all talk about mass conservation is a flooding period. Okay. So that's the third question. Okay. So that's why semi-impressed skin does not really help you. Another thing, semi-impressed skin, the flooding drying not as good as a most severe coating. The reason because when the topography very complicated, right? So you matrix, sea level matrix solve, sometimes not converging. Okay, the time we testing the time step for internal mode, semi-impressed skin and the mostly coated flooding drying for internal mode time step is same. Semi-impressed skin we are not able to make a create a longer time step. Okay.
Would you tell me the last part again? I don't.
Sure. For example, you use like a barotropic time step. Okay. Something, for example, you use like a no 1 second. So you get a barochromic time step, internal mode time step. For example, you get a 10 second. Right? So that's why you will run for mostly coded 10 seconds for internal mode time step. But when you use semi-impressed skin, you get time step for semi-impressed skin is about a 10 seconds. So you make a lot, you're not able to significantly make like a 14, like a 20 second. No, this model will understand the reason because of matrix converging issue. But you need to solve the matrix. Right? That's why for flooding drying case, so we recommend use the most slip because most slip coating, it's more easy. So you can avoid sometimes for example, forecast system avoid the matrix converging issue. Okay. So another question, another question for the MPI. Okay.
Dr. Chen, there is still one related to the eye split. Maybe we can solve it together.
Which one? Which one?
This one, the current one.
Yeah, that's why, that's why, that's why I sort of, as the answer is the question, if the ratio equal to 1, does the mass conservation decrease, increase, and how much is the change? That's why I already answer. Okay, if you're equal to 1, even you're not equal to 1, when you're flooding period, if you're mostly coated longer, this integration is not equal anymore because some triangle area was changes because you get a barotropic case, internal mode, you get a one-time step, you run for internal mode, the flooding drain is internal mode, right? Sea level is calculated while a short time step. Because but the internal mode time step and the short time step, sea level, if when the flooding joining, because some regions become wet and dry, right? So then your mass conservation could be the problem, not a conservative, right? When it becomes equal to 1, it's similar. They just have the internal mode only. You don't have a sea level error anymore. That's why you conserve. But all we're talking about is flooding period. Okay? When the water becomes wet, become dry to wet. Okay? So when it becomes wet to dry, they do lose the volume. Okay.
So, Professor Chen, I think you mentioned two issues.
Yeah.
One is between flooding and ebbing.
Yeah.
So when from a certain cell, the mass is conserved from dry to wet, but not from wet to dry.
That's correct.
So, yeah. So in that case, no matter what time integration method used, it cannot be avoided. That is one of your point.
Yeah.
But actually one of students asked question is about the time the I split. So if the slope is steeper, then you mentioned that I split should be even more.
Yeah, no.
I
I
think
put it like
would
this
you
way. Yeah. If
no go
you
back
no,
the
I
first question?
probably
First
start with the
question.
question. Yeah. The question, I understand that he said question one is now if you have I sleep, equal to one, definitely you can run more stable than you have the most sleep. That's definitely no question about this. But then no, I sleep, right? Equal to one, but you look like you use the only barotropic mode,
Mhm,
right? Because sea level, you don't have internal mode anymore. Okay.
mhm,
I should
mhm,
want. That's why
mhm,
it's always more stable than I sleep larger than one.
mhm,
Right? Because larger than one, because the reason because if I sleep equal to one, you don't have a problem water conservation issue when the flooding period.
mhm,
But in I sleep larger than one because your sea level comes short time step because most of flooding prediction is based on sea level,
mhm,
right? So then your internal mode, time, internal mode sea level calculation probably not accurate as your barotropic mode, so calculation sea level. That's why you can see your prediction, the sea level, that's not a water conservation issue. The issue is you don't have, you don't match each other. That's
mhm,
why you get a numerical error, make a prediction of the flooding.
mhm.
Okay, that's
But
the issue I show over there. Okay.
but the question is if the slope of the intertidal region is steeper, then the I split value, meaning the ratio between external and internal, is larger, should
No,
be large.
no, it's really dependent. When you have a more steep topography, okay, you should isolate number. You should be choose like smaller.
Mm-hmm.
Because that's dependent on one times the how the sea level change is,
Mm-hmm.
right? Because you're still topography, your sea level can be changed. One times it can be changed a lot than the
Mm-hmm.
flooding topography.
Mm-hmm.
This way, if you use a larger slip number, right? So this can cause the model is unstable,
Mm-hmm.
right? That's why you look up here, you look up here, you look at the picture here, I could see that's the 10 minus 4, 7, 9. You see the slope position, alpha slope,
Mm-hmm.
right? Alpha slope. So then you look at ratio, the time ratio here. So this one you see here, okay, I couldn't see this one here, okay. Okay, I couldn't see. That's why that's also depend on the sea level, right? Your sea level, that's the water level, right? If water level is larger, okay, you see water level change larger, you all three methods need to be go to a very small hand slip.
Mm-hmm.
You see over here, when the water level is smaller, right? For example, 0 smaller. So then this one I couldn't see this very clearly. So which one? This one, you see, the steep one. Can you make the zone bigger? Is it possible to make the picture bigger?
Yeah, I will try.
Then I couldn't see that. Yeah. You see here, you look about here. But the steep topography, this is this one is this larger one. You see over here, you do see when the sea level is smaller, you can get your ratio, can be bigger, right? Can be bigger, but sea level is very small, right? But when the sea level go too high, this ratio all becomes smaller, right? So, but the ratio here, you see this converging very fast, converging there. But then this ratio, but that, so remember, that is ratio is a baroclinic mode to the barotropic mode.
Mhm.
Okay, so that means your how many times that you can have. But this idealized case not mean lot of thing. But really case right now. So because that's linear case, really topographic case, sometimes sometimes the condition can be reversed.
Mm.
Okay,
Okay.
right? So the convert, but this one here look like okay. I think something look like this one. You see here, this larger slope, this small slope, but all you can see the slope here, no much difference because they're all same order,
Mm.
right? Same
Mhm.
order. So I mean, so when it's very simple topography, very simple topography, you can see, for example, 0.2, but it's all this all tested cases don't really make sense. The reason because they all -4. It's a very general topography.
Mhm. Mhm.
Right? But when you go to -2, -1, that could be reversed.
Mm.
Okay?
Okay.
Right? That's why this picture is a little bit misleading.
I see. Okay.
Okay, the
I
Dr.
think
Didi, right?
maybe that's the reason why he asked a question. Okay.
Yeah, that's a misleading picture, okay?
Okay.
Right? That's a
Okay.
wrong in there. You can see that picture really make the reason because you can see that's a very general topography, almost -4. Okay?
Mm. Mm.
Right? You see here, that's why you can see oh, ratio can be really big, okay? Right? Go to 100, like this way. But the model is really stable in this case.
Yes.
It's pretty much different. When the topography really steep, okay, when the really case there, okay, time step, then your time step has to be really small. Because depending
Okay.
on, there should be, we should be seen as it's not a sea level, should be delta 6 theta. This color should be this one.
Okay.
Okay, not for absolute sea level.
Mm.
As we did a long time ago, but now we do the more wrong, we find that is critical.
Mm.
Not zeta critical, this is critical. We should update the manual, okay?
Okay.
Okay, yeah, that's now I know why you ask this question, okay?
And final question
Final
about the
question is
uh
about FPI.
yeah, MPI. Yeah.
Your question is now, you said when you don't have a dike, okay? So, question here, so we have a dike and a crown. Dike, like dike is this called dike. This is dike. I think this called dike crown was there. If you without a dike wrong, you see, when you don't have a dike, there are hundreds nodes, no hundreds nodes, and they can be divided as a 10%. That's correct. That's no problem. But no partition generally distributed such as contain the 8 node, when the other contain the 12 node. What mean for that? Okay.
I think he tried to mention that when there is no dike,
Yeah.
each domain is kind of similarly distributed to each computational node.
Yeah.
But if there is a dike,
Mm.
then the partition should be made near near the dike. So
Uh-huh.
what is the how those computation I mean how does calculation nodes should be distributed to the each
Oh, that's
yeah.
that's first question. That's done automatically by the MPI, MPI program. Okay, so if you tell them, the node you have to decide after node decided, right? Because you use to define like I use 10 node, right? No, MPI program automatic decomposition into decomposition the domain, automatically. We don't do anything, okay?
Mm, mm,
Right? So then the basic what they do just depend on how many seer into the model. Right? That's the reason you can see some region, you can see some regions are very high, some regions are very larger. That's because it's no much node here. Some of the region have a much node. But all the cell number should be equally, most equally in the each decomposition domain. Okay, that's why the region here could be this is a very high resolution. Probably choose a high, probably high here. Okay, right? So that's randomly. So then they're not randomly. They a program determine, but we can do nothing to do that. Okay, just automatically determine. The second way, no.
Dr. Chen, so sorry, I want to add something. So, when there is no dike, so the partition is divided randomly by the Matisse library. However, when we add some dike inside the model, actually there is an input file determining the dike location. So after that, FVCOM will set manually those dike calculated on one CPU. So, for example, here, for this case, there are totally 8 CPU applied, and you can see this is 1, 2, 3, 4, 5, 6. But however, you can also see the two dike is in two different colors, which means that the two dike is calculated separately on two different CPU. So the reason is that if we just allow the Matisse to do the partition, so the Matisse will sometimes will just cut one dike into two pieces, which makes the calculation too difficult. So when we add the dike calculation, we set them manually.
Okay, yeah, that's probably I don't know much. That's after the changes one. No, I think Dr. Lee says it correctly. No, he just for die and the CRUM module. So this separated CPU calculated. Okay, then they put all die is no because if you look at FVCOM coding, that's correct. So we had a die module really calculate for die, right? So then we merge it together. Okay, this way, the reason because die, for physically we designing, so we find, die we have to treat specially because you have a calculation sea level, if you have die over here, you need to calculate sea level for cell on the left cell and the right, so merge together. So that's why if you if you do like regular MPI doing this way, so they get into trouble, right? So sometimes you don't know if they had the die was a boundary divided as two domain, you're not able to calculate it. That's why Dr. Lee says correctly, we separate it. That's
So
the you find it's different.
So I think that leads the second question. So if the user can define where need to be partitioned, like using dike, that means in case when there's no dike, the people also can choose the partition manually. That is, I think, his second question.
Oh yeah, that's the one. The Dr. Lee can answer this one. I don't think we can do.
Yeah, no. Currently, we can only set the dike cells and nodes manually. For all the other, no matter inner or boundary nodes, we cannot set them manually. So it will all the other region will still be divided by Matisse library.
No, before when do the test case, when FECOM developed, Dr. Wang, he used to manually determine like a decomposition, like determine which how the because with the idealized case, he don't use the Matisse. He just because he know what exactly he developed manually. Okay, then make a decomposition parallel for the input file like this way. But then that's for ideal like he can do that. But really application can be very hard to do that. very hard to do it. Okay, because for example, he had a very simple case like a calendar, like a circle, like a circle lake, also like like a sector, like just like a rectangle, right? He can manually determine that. Okay, but but if you like a very complicated case like S3, you're not able to do that.
Mm.
That's the only-
So in the case, the picture that we saw about the domain decomposed situation, the lower part. So if the CPU is distributed in that way, then is that okay or not? In a Sicily, I mean, so first, I mean, in the if
This one.
is
This
that
is
okay? Okay, is that okay distribution or not?
this is the right decomposition.
So even though the die can be okay, I see.
Yeah, this should be okay.
Yeah.
But
So
now you can see more clear because I didn't see this one here. You see the color? You see the color, this blue, this red. That's one node here, one node here.
Yeah,
Okay,
right.
right? So you see that this is you see that's the blue one here. The red one is the total is 8, right? Total is 8,
Mhm.
right?
Mhm.
yes.
1 to 8. You see the blue and each blue is the one. But I didn't see that's why you can zoom picture. I can see that. Okay, see this? That's the one node. That's another node.
Yes.
Mhm.
Okay,
I see.
so we want to make sure all the die is collection on the one node, but then you had to separate because this is not this is separated. That's why you can have a 2 node.
So does that, because the only compared to the other, let's say in that picture for the CPU 7 and 8
Yeah,
only calculate die nodes,
yeah.
Yes.
but the other 6 CPU will cover all the other
Two
areas.
other. That's correct.
Yes.
That means for the CPU 7 and 8, the computational cost might be very small because they have to calculate only small number of nodes compared to other 6 CPU. Does that also cause any problem or inefficiency?
When let me answer the question. When we do the die calculation, we do find a computation to slow down.
Mm,
Reason because if the die is notice very smaller, so they spend the time very fast.
mm,
So then when the die was finished, sometimes die is high resolution over there. Die can take more time. The OCP had to wait.
mm,
Right? We do find that when we put a die like this ideal case, you didn't see much difference when we do the Changjiang River, the really case Changjiang River, right?
mm.
The case there, we do find out, die spend more time to calculate it,
Oh, I see.
right? Because it's
Mm,
very high resolution die over there, the region. So then we find it so computation time will slow down.
mm, mm, mm.
They do slow down.
Nice. Okay.
Right? So for this one, he can see use a 2 node for more complicated case. Like this one,
Mm,
if more complicated. Most time we don't worry about too much because most of we get a seawall.
mm,
The seawall only one line. Okay, the
mm,
code.
mm,
That's why we just use the CPU, but it's kind of fast, but it's not a significant change because that's most all other domain calculations more times much slowly than a die. So die
yes.
don't cause a problem, just waste of one node.
Right.
But
Right.
when for the Chaojiang River, we do find a slowdown.
Mm,
Okay.
okay.
I don't know how much but first things I think if without a parallel rounding, we think no, we do have a problem. I think we slow down like 30% after parallel. I don't know how much is. I couldn't remember. Okay. Okay. Then all question.
Yeah.
Now times now had more asked question.
Yeah. Is there any other question?
It's
Oh,
Zhang is come from Zhongshan University, right?
oh.
I think yeah.
Yes. Hi, Professor Chen. Yeah, I and last time I didn't know this the online discussion, so I come here today.
Okay, okay.
Welcome. Actually, Rizhang also asked us some question on the discussion board, and I answered them. So if anyone interested in those questions, three related to the mesh generation. So please feel free to discuss there.
Yeah.
So if there is no other questions, so we may end it up here. Thank you so much for joining this
Dr.
discussion.
Lee has put like the vaccine limit on the chat. You see there, make include 5. Right, you had a flag 8. No, you see that's one there. You can see that, okay?
Yes.
No, when you do the flattening drying, you better turn on this for X-ray.
It is in the make RNC file. So after change this, please make sure to recompile your coding.
Okay.
Mhm.
Okay, good. Okay.
Yeah, so if there is no other questions, so we may end it up here. Thank you so much for joining this discussion, and see you next week. Bye-bye.
Thank you. Bye-bye.
Thank
Yeah.
you.
Bye bye.
Thank you.